So today what we're going to be working on are forces. So I'd like you to put me on pause and do the try this and then come back and check your answer, please. Okay, so it says in quadrilateral ABCD, AE is drawn to form triangle ADE. If AD is equal to 6, AE is equal to 10, and angle AEAD is equal to 25, find ED to the nearest tenth. All right, so let's look at our picture and we'll mark our picture here. So I have AD is equal to 6. AE is equal to 10. And we have angle AEAD, that's this little angle in here, is 25. And we're looking for ED. So notice what I have here. I have a side. Angle side. So I have 1, 2, looking for the third side, and I have the angle across. That would be the law of cosines. So remember the law of cosines is a squared equals b squared plus c squared minus 2bc cosine of angle A. So remember the ends have to match up to each other. So if I'm looking for this side A, I have to plug in angle A. So it's x squared equals 10 squared plus 6 squared minus 2 times 10 times 6 cosine of 25 degrees. So since the whole right side is plugged in, I could plug it into the calculator all one time. So I get 27.24306,556. Take the square root of both sides, so do second square root, second answer, and we get 5.219. To the nearest tenth would be 5.2. All right, so now let's talk about forces. All right, so a force is a vector quantity that has magnitude, which means size, and direction. So let's say we have a box, and the box is pretty heavy. So I get somebody that is stronger than the other person, but only slightly stronger than the other person. So somebody that has a force of 3, that's going to move it with a force of 3 to the right, and a person that's a little bit weaker, and it's going to move it to the right in the same direction as the other person with a force of 2. So together their combined force is 5 to the right. So that's 2 plus 3. You get that by, since they're going in the same direction, it's 2 plus 3. So it's a force of 5 to the right. All right, so now if we're going in opposite directions, so if we take one person that's has a force of 5 to a really strong person, much stronger than the person on the left, a force of 5 to the right, and this person, who is obviously much weaker because it's only a force of 2, is going to the left with a force of 2. So what's going to happen? If a strong person is going to right, a weaker person is going to the left, which way is the box going to pull? The box is going to pull to the right with a force of how much? So what you do is you do 5 minus 2, and that's a force of 3, and it will go to the right. So it'll go to the right, not as quickly as it would if 5 was just doing it by themselves, because 2 is giving it some resistance on the left. All right, so now if we have a box and I have 2 forces that are going in a direction that are creating an angle here. So once they're like going on a diagonal. So what happens is that, so when you pull, the box is going to go, it's going to go in between the 2 forces, and it's going to go closer. So the box will go like this. It'll go closer to the stronger force because that force is pulling it closer to them. So it would go like this. It would go like that. So it's between the 2 forces, but closer to the stronger force. All right, so let's write down some information down here. So it says, when 2 forces act on a point, the single force has the same effect as the combination of the 2 applied forces. So that's what I just talked about here. That's called the resultant. So this line here is called the resultant force. So on this picture, notice I have my 2 forces. And when they pull in those directions that create an angle, they create this force here called the resultant. Now, what's important about this is that this actually creates a parallelogram. So if I take this force here on the force 2 and I bring it over to the right and then drop it down here, notice I just created a parallelogram. So it creates a parallelogram. And what's the resultant? The resultant is the diagonal of the parallelogram. So the resultant is the diagonal. And what are the forces? The forces are the sides of the parallelogram. All right, so right here in this section here, where there's 2 stars, we have to write something that's pretty important, and that would be this. That the resultant, this diagonal here of the parallelogram, it is not, I repeat, it is not an angle bisector. So the resultant is not an angle bisector. So which means it does not take the angle here. It doesn't split it in half so that this is equal to this. That would only be true if it's a rhombus. And it would be a rhombus if my forces are equal to each other. Okay, so let's flip it over and we'll do a couple of problems. Okay, so let's take a look at number 1. It says 2 forces of 25 and 15 pounds act on a body so that the angle between them, should be them, is 75 degrees. So let's start drawing a picture. So we have 2 forces, 25 and 15. It doesn't matter which one you make 25 and which one you make 15. But I know the angle between them is 75. Find to the nearest pound the magnitude of the resultant. So I'm looking for the resultant. Remember that resultant is the diagonal. Remember that creates a parallelogram. So I'm going to drop to the right and then down. Creates a parallelogram. So I'm looking for the resultant. I'm going to make that X. And then we have another part. So let's do the first part. Find the resultant. Now, so when I draw in my diagonal, I do create a triangle. I create 2 triangles. And the triangles are equal because remember the diagonal of a parallelogram splits the parallelogram into 2 congruent triangles. So I have this triangle here. Now notice the 75 that was here, this angle. That angle is only partly in the green triangle. So I can't actually use that angle. So what I'm going to do is I'm going to use another property of the parallelogram and find this angle here. Why? Because I know that consecutive angles in a parallelogram, angles that are right next to each other, top, bottom, side to side, they are supplementary. They have to add up to be 180 degrees. So I'm going to do 180 minus 75. So angle Y is 105 degrees. So let's put that in here. So this is 105. Okay, one other thing I know is this, is that if this side here is 15, I know this side here is 15. So let's look at this green triangle that we have here. So in the green triangle, I know this side is 25. This side here is 15. I'm looking for the third side, and I have the angle opposite the third side. So what do we use? We use law of cosines. So remember, law of cosines is a squared equals b squared plus c squared minus 2bc cosine of a. So I have x squared equals 15 squared plus 25 squared minus 2 times 15 times 25 cosine of 105. Since I have the whole right side, you could just plug that whole thing in at one time. And we get 1044.114284. Second square root, second answer, 32.312. To the nearest pound, that means a whole number, that would be 32 pounds. All right, so now I know this here is 32. 32 here. Okay, so now let's see what it says. Now it says, find the angle to the nearest degree formed by the resultant, so the resultant, and the smaller force. Now this one here is my smaller force, right? So I want the angle smaller force and resultant. So I'm looking for this angle right here. So now I kind of want to stay inside my green triangle, so I don't have to switch over to my other triangle. So I know that this angle here is congruent to this angle. So hopefully you remember alternate interior angles, right? Alternate interior angles, they make that Z. They are equal. So I'm going to find this angle here. I'm going to make that Y. So let's see. In the green triangle now, I'm looking for this angle. I have the side opposite. I have angle 105 and I have the side opposite. So yeah, you guessed it. We are going to use law of sines. So that's A over sine A equals B over sine B. So I have side 25 over sine of angle Y and side 32 over sine of 105. Cross multiply, so I get 32 sine Y equals 25 sine 105. Divide both sides by 32. So I get sine Y equals, so plug that in your calculator, you get 0.7546. 0.7546295518. Remember, we're looking for an angle, so we do second sine, second answer. We do the inverse key. We get 48.99, which is 49 degrees. All right, so let's take a look at number 2. Just going to move everything out of the way. All right, so number 2 says, a resultant force of 143 pounds is needed to move a heavy box. 2 applied forces act at angles of 36 degrees and 47 degrees with the resultant. Find to nearest pound the magnitude of the larger force. Okay, so let's draw a picture. We have a resultant is 143 pounds. So remember, the resultant is the diagonal. So let me create my parallelogram. So this is 143. And it says 2 applied forces act at angles 36 and 47. So it doesn't matter which one you make which angle. So I'm going to make the bottom one 36 and the top one I'll make 47. And it says find the magnitude of the larger force. Now which one of these is going to be the larger force? Is it this one or is it this one? Well, it depends on where you put your angles. So the larger force will pull the resultant down further closer to it, creating what kind of angle? A bigger angle or a smaller angle? It'll create a smaller angle. So this one here is my smaller angle, 36. So that means this one here has to be my larger force. So I'm going to put an X right here. Okay, so let's look at this triangle here then. So in this triangle, since I'm looking for this side, right, I'm going to have the angle opposite. So I know this angle opposite, let me just go a little bit bigger here. The angle opposite has to be equal to this angle because they're alternate interior angles. So that's 47. Since I have this side, it would be nice to have this angle that's opposite. And I can get that because all the angles of a triangle have to add up to be 180, or consecutive angles have to add up to be 180. So I have 47 and 36. So 47 plus 36 is 83. So 47 plus 36 is equal to 83. This angle here is 83. So that's 180 minus 83, and that's 97. So this angle here is 97 degrees. So now which law can I use if I have side, angle opposite, looking for a side, angle opposite? You guessed it, we're going to use law of sines. So that's A over sine A equals B over sine B. So it's going to be x over sine 47 equals 143 over sine of 97. Cross multiply, we have x sine 97 equals 143 sine of 47. Divide both sides by sine 97. So just plug this into the calculator all at one time. We get 105.36. To the nearest pound would be 105 pounds. Okay, so that's it. And just so you guys know, this is one of my favorite things to do. I love to do forces. So we will definitely be practicing class for a couple days. So why not, right? If I like it. So let's work a couple days on it. All right, have a good night, everyone. See you tomorrow.